Okay, you rascally little chemistry students, we're moving on to the second part of ChemQuest 30, your intro to stoichiometry. We're going to focus on critical thinking questions 5 through 7, sort of putting things together in a new context. All right. So for numbers 5 and 6, we are still going to stick with this initial propane reaction that we've been doing for the last couple of days, just to build familiarity there before we move on to new types of reactions. All right, but we're going to walk through the whole process. A, B, and C is a good little outline of all the steps involved, with the exception of the fact that the balanced reaction is already written for you. We are not always going to do that. We will ask you at some point to synthesize, writing out and balancing a reaction, then going through the steps to calculate quantities of the products and so on. But for now, we'll let you start with the balanced chemical reaction just to make it a little bit less cognitively demanding at this point. But let's jump in. If we have 410 grams of propane, so in this case, right, we want to know grams of oxygen. So question mark grams are required to burn it, right? So now, what we want to know here is if I have 410 grams of propane and I want to burn all of that up, what is the minimum amount of oxygen gas I need in the presence of that propane in order to burn it all up, right? And that does emerge from this 1-to-5 ratio. We have to remember that 1-to-5 ratio is a mole ratio, right? The amounts we have here are in grams. So, of course, like always, we're going to have to convert quantities to moles, right? So step A says find the number of moles of propane, right? And we know grams. So we're just going to go 410 grams, C3H8, right? Now, to go from moles to grams, you guys have already learned this. We divide by the mole mass. So I'm going to hit divided by 44.11 grams, C3H8, per 1 mole, C3H8. All right? And we are dividing by like units. So I'm going to cancel those out, so this will give me my answer in moles. And when I do so, I get a total of 9.3 moles, C3H8. In that case, right? And we would round to the second sig fig because this number right here has 2 sig figs. The 4 and the 1 at 0 is not significant, so this number only gets 2 sig figs. All right, letter B. The moles of propane are related to the moles of oxygen by the ratio of coefficients in the balanced reaction, right? And we've been talking about it. It's a 1-to-5 ratio. For every 1 mole of propane, we need 5 moles of oxygen. So since we have 9.3 moles of C3H8, right? We want to find the number of moles of oxygen. So this is what we're going to multiply by the mole ratio. All right? So I'm going to hit multiply, and I'm going to set up my ratio as a fraction. We're starting with moles of propane. So moles propane goes on the bottom. We want to know moles of oxygen, so I'm going to go moles O2 on the top. And this is where I go to my balanced reaction. There's a coefficient of 5 with oxygen, so the 5 goes next to the moles of O2. There's a coefficient of 1 there, so I'm just going to go 9.3 moles of propane times 5 over 1, and I get 47 moles of oxygen. Okay? Now I know I have 47 moles, or I require 47 moles of oxygen to completely burn up 9.3 moles of propane. All right? But we want our answer here in grams, right? So we know the moles of oxygen. So again, you guys already know how to do this, right? We should end up with an answer pretty close to 1,490. So we're doing a verification here when I convert moles to grams. So if I have 47 moles of oxygen gas. All right, so going from moles to mass, I'm going to multiply by the molar mass, right? So in this case, the molar mass of oxygen, 2 oxygens, 32.00 grams O2 per 1 mole O2. And when I do so, I get, well, with sig figs, 1,500 grams of oxygen. So the ChemQuest guys here added an extra sig fig. We don't know that. 2 sig figs there. That has 3. Shame on the ChemQuest people, right? So properly rounded in this instance, we should end up with 1,500 grams of O2, but very close to 1,490. Right? If they put a little dot right there to indicate that 0 is being significant, we would have had more sig figs to work with, and we would have gotten that 1,490. All right, number 6. Boom. Last question where we're giving you, or we're still using the original reaction of propane combustion, right? If 315 grams of propane combusts, then approximately 500 grams of water are produced, right? We want to verify that. So we have 315 grams ought to produce 515 grams, okay? So we're going to verify with stoichiometry that that's the answer we ought to get if we do this, right? So basically we're just going to take all those steps we just did, we're going to combine them, and they're not splitting it up for you. So a little bit taking off some training wheels here. So we're going to start with our quantity, 315 grams of propane. All right, so first step is convert to moles. So I'm going to divide that by 44.11 grams per mole. All right. Oops, sorry, excuse me. Habits. Right, so we're going to cancel out our gram unit, and when we do that, we should get 7.14 moles of propane. Okay, so that is, so here's our step 1, is balanced reaction. Step 2, convert known quantity to moles. Step 3, we're going to multiply it by the mole ratio. All right, and so I have 7.14 moles of propane times our mole ratio, which is going to be moles of propane on the bottom, moles of water on the top, and this is a 1, and this is a 4. So 7.14 times 4 over 1 equals 28.56 moles of water. All right, that's in moles. So our last step, we're going to convert to our desired unit. We want to see if we get 515 grams here. So I'm going to convert moles to grams. All right, so I've got 28.56 moles of water. Stupid L. Right, going from moles to grams, we multiply by the molar mass of water, which is 18.01 grams per mole. And we should get 515 grams of water. Woo! Verified. Check. All right, number 7. Last one for this video. So it says, consider the decomposition of ammonia. All right, so we're operating with a new reaction here, but again, they were kind and balanced that for you. All right, if we start with 425 grams of ammonia, so we're going to go 425 grams here of ammonia. How many grams of H2 and N2? So we're going to find 2 different quantities. Question mark grams. Question mark grams. Can we produce from 425 grams of ammonia? All right, so step 1 is that balanced reaction. Done. So we're going to take our known quantity, which is this guy. In step 2, we're going to convert that to moles. So 425 grams NH3, right? We're going to divide that by the molar mass of NH3, which is 17.04 grams NH3 per 1 mole NH3. Cancel our grams because we're dividing by grams. And that will give us 24.9 moles of ammonia. All right, so step 3, we're going to multiply by our mole ratio. We're going to do this twice, once for hydrogen. So I'm just going to label this hydrogen, and then again for nitrogen. That way we just do these simultaneously since it's the same step. So in both cases, we have 24.9 moles of ammonia. All right, and what we're going to do is we're going to multiply each of those by the mole ratio. All right, so in the case of hydrogen gas, we have a 2-to-3 ratio. So I'm going to set up my ratio here. Moles of NH3 on the bottom. All right, the coefficient with ammonia is a 2. All right, moles of hydrogen on the top. The coefficient with hydrogen is a 3. So if I go 24.9 times 3 over 2, all right, I get a, let's see, 37.35. So I'm going to go 37.4 moles of hydrogen on this one. And then for ammonia, we go mole NH3 on the bottom, and that's a 2. And then moles of nitrogen, the coefficient there is 1. So I'm going to go 24.9 times 1 over 2, and I get 12.45. So we'll go about 12.5 moles of nitrogen. Okay? Now, if it asks for moles of each, I would be done, but it's asking for grams of each. So for step 4, I'm just going to basically do the same thing, 2 calculations, one for hydrogen, one for nitrogen. I'm just going to convert those quantities to grams by multiplying by the mole mass. So I have 37.4 moles of hydrogen gas times 2.02 grams H2 per mole H2. Sorry, whoops. Boom. Quick correction there. Cancel the wrong unit because I'm getting impatient. All right. And in that case, I get 75.6 grams of hydrogen gas. And do the same thing for nitrogen, 37.4 moles of H. Sorry, this is NH. Nope, that is H2. Man, too early in the morning. Moles of H2, N2. Okay. Times molar mass of nitrogen, which is 28.02 grams N2 per 1 mole N2, and I get 349 grams of nitrogen gas. All right, now one thing we could do to double check our work is if I add those two together, I should end up with something pretty darn close to 425 grams. So let's check that. Let's go 75.6 plus 349. I get 424.6. Now, because of sig figs and rounding, that's pretty darn close to 425, right? So that's a good way to double check our work. Conservation of mass says total mass of products has to equal total mass of reactants. 425 grams to start. This plus this also equals 425 grams, so we did things right. Adios, Chuck.